All right, now that we've finished with the theory and estimation of production, we can move on to the theory and estimation of cost. In this chapter, we're going to begin by looking at the importance of cost in managerial decisions. We'll move on to the definition of cost and then how we use them in economic analysis. Then, once we understand what cost is, we can develop a relationship between production and cost and see how what we learned in the last chapter is going to apply to this chapter. We'll then look at the cost function in both the short run and in the long run. Move on then to the learning curve, and then look at economies of scope and scale. We'll end by looking at supply chain management and the way that companies have to try to reduce their costs in order to remain competitive in a modern day business environment. Trying to minimize or restrain costs has been an important component of managerial decision making for several decades now. When you think of that, it instantly draws to mind like the 80s sharks in their pinstripe suits with their slick back hair. Or maybe more recently, like in 2010s, you imagine, Bain Capital buying up these businesses, retooling them, shutting down, firing off like half the employees. Sometimes, and especially early on, this was necessary because companies are getting big, or we're getting big and bloated. Um, but there's been a lot of different methods that managers have used to try to go about this sort of cost savings. So one of the most common is just to reduce the number of people on the payroll. Sometimes it's as simple as taking off a layer of middle management that really doesn't add that much that's productive. Sometimes it's shutting down unprofitable business lines and then anyone involved in the production or the sale of those products. Another method that they've done is consolidating what's called shared services. These typically refer to consolidations of things that are considered more back office and support functions. So things like finance and accounting, IT, HR. Oftentimes firms will contract with an outside firm to handle those for them. This goes back to Kosa's idea of the firm dealing with transaction costs. Now transaction costs are low enough. I guess because we're able to connect almost instantly through the internet, we can have outside IT or outside HR that deals with everything in almost real time without huge costs and delays. So firms can save money that way. Another method has been outsourcing or offshoring components of their business. So they're optimizing their labor by finding an alternative location for their facilities. So for example, take an auto manufacturer located in the US. They may move some of their early stages of manufacturing to Mexico. The labor costs are much lower there, and there's a less skilled workforce there. You keep the final assembly, or they keep the final assembly in the United States because you need a labor force with greater human capital, so more education and experience working with, the type of machines that are necessary to do the final stage production. But the simpler stuff early on, move that to a location where it's less expensive and where they have the skills that are necessary to do that. And finally, there's mergers and consolidations. Typically, these are accompanied with a reduction of employees. So you combine two firms that are in the same industry, lay off some of the staff, and then you end up increasing productivity there. The hope is that you increase productivity of those workers. There's an old HBO movie called Barbarians at the Gate that shows this process of people negotiating for trying to take over a company. I highly recommend it. I thought it was really interesting. It was a true story about Nabisco back in the 80s. So within firms, it's typically the accounting department that worries about costs the most. But for the purpose of internal analysis and for long-term firm decision making, managers also consider cost, but they do so based on whether the cost is considered relevant or not. So relevant cost is going to be a cost that is affected by a management decision. So anything that they can impact, anything they can reduce or add based on their choices is going to be a relevant cost. Anything that's set in stone, that they cannot affect no matter what they decide to do, that's not going to be something they consider in their decision making. So both economists and managerial accountants use the concept of relevant cost when they're trying to analyze a problem the business is facing, reach some kind of solution, or recommend a future strategy. Now there's another type of cost worth mentioning called historic cost. This is the cost that's incurred at the time of procurement. So if it costs you, $750,000 to purchase a large shipment of something they're going to use in the production process, some input, and the value increases then to $1 million, the relevant cost of that now when you're trying to reach a decision is $1 million. But the historic cost is the cost what it was to you originally. So that's the $750,000, the original value, how much you spent on it. And finally, uh, any discussion of costs in economics isn't complete without considering opportunity cost. So opportunity cost, remember, is the amount or the subjective value that's foregone in choosing one activity over other various alternatives. In this case, it's going to be how else a firm can spend their money or what other line of business they can get into. We consider this an indirect cost or an implicit cost, while the out-of-pocket costs are direct costs or explicit costs. All right, so let's think of that firm purchasing the $750,000 worth of computer chips for an example. But instead of the value increasing, let's imagine that the value of those chips that they purchased decreases from $750,000 to $550,000. So in this case, how much does it cost? What is the cost that the firm is facing? To answer that, we need to introduce two additional concepts. The first is incremental cost. The incremental cost is going to vary with the range of options available in the decision-making process. So based on what the firm chooses, that's how much the cost is going to change. On the other hand, sunk cost is not going to vary based on whatever decision the firm makes. No matter what decision the manager decides on and however they act and direct the firm to act, there's not going to be any change. You have to pay that sunk cost. All right, so what are the costs here? The firm has already paid $750,000 for the chips. That can't be recovered. So the decision's facing the firm right now. They can either sell those computer chips for the new value of $550K, or they can eat their expenditures, how much they spent on it, and earn no money. So the $550,000, that's an incremental cost. The firm is able to earn that based on their decision making. So that it may cost them that much money if they choose not to sell it, or they can earn that money back and it won't cost them. So that's an incremental cost. The $200,000 is a sunk cost, the difference between how much they paid originally for those chips and the new value that they could potentially sell them at. No matter what the firm chooses to do, they cannot make that $200,000 back. So that's a sunk cost. Now, at first, it may seem like the entire $750,000 is going to be sunk because that's a decision the firm made and they can't go back on it. It's not like they can just sell it back. But that's not the case because the firm can do something about it. They can turn around and resell them, even though they can't return it to to whoever they purchase it from. They still have a future decision they can make about it. So our economic analysis of cost is going to be very closely related to the economic analysis of production that we used in the previous chapter. So the cost function is simply the production function expressed in monetary units, so it's expressed in dollars, rather than the physical units like we did in the previous chapter. And it's going to contain all the assumptions we use for the short run production function for the short run cost function as well. So remember, one of those, we're assuming competition, and we're assuming that in the short run, at least one of the inputs are fixed. But we're going to add one additional assumption to this. We're going to assume that the firm acts as a price taker in the input market. So by price taker, we mean that as long as it pays the going market rate, so they don't have the ability to set prices, they have to respond to the market rate. But as long as they're willing to pay that, they can hire or use as many or as few as inputs as the firm desires. Our total variable cost, which we abbreviate as TVC, is the cost associated with the variable input, so the variable labor input. Typically, we're working with labor, and through our examples in this chapter, it will all be labor. We can calculate that by multiplying the number of units by the price of the unit. If we plot these numbers for the total variable cost on a graph, we could see that the total variable cost is a mirror image of the total production. We also have to consider marginal cost, so the rate of change in total variable cost. So marginal cost equals the total variable cost divided by the quantity being produced. Now, when the firm's marginal product is increasing, its marginal cost of production is going to decrease. And when its marginal cost of production is decreasing, its marginal cost is increasing. When the marginal cost is increasing, that's when the firm is experiencing diminishing returns. All right, so here we plot the total production and the total variable cost on a graph. Now, the y-axis is going to be the quantity that's being produced in thousands. And then on the x-axis, we have the cost or the labor units. So we have the cost for the total variable cost and the labor units for the total production. And we can see that they follow their mirror image of each other. They follow the same way. So we see that when total variable cost is increasing very slowly at the beginning, the total production is increasing very quickly as we're adding more units of labor. Now I hesitate to include this because this does look a little confusing, especially because we're flipping around the one axis. But it basically is just to show you how they mirror each other and how at different points in the production process and at different levels of labor inputs that we're using, we're going to be experiencing costs going in the same way. Again, because our variable costs are going to be as a result of labor in our examples. Before we work through the model of the firm's short-run cost function, we need to just highlight the assumptions. So for our model, we're going to assume that the firm is going to employ two inputs, only labor and capital. Just like in the last chapter, we're going to simplify it. So we have capital as the fixed input in the short run and labor as a variable input in the short run. So the firm is going to is going to produce a single product. We're not going to be producing multiple separate products which have different cost functions. Ends up confusing too much. Again, we're trying to understand what the relationship is here, not fully go through what a specific firm is doing. And finally, the firm is going to employ a fixed level of technology. We're not going to change the type of capital or anything else that we're using during this time period. Productivity is going to remain the same. Anything involving technology is not going to change. We're also going to assume that the firm operates at every level of output in the most efficient way. Again, anyone with experience working for a company knows that that's not going to be the case, but we're going to imagine that again so we can understand these relationships. The firm operates in a perfectly competitive input market, and they pay for their inputs at the market rate, so they're a price taker. Basically what that means is they don't have market power that they can tell a producer that they don't want to pay, that price, they're going to pay less. They're not able to negotiate down. They have to take whatever the market rate is. And finally, the short-run production function is going to be affected by the law of diminishing returns. We're going to assume that this is happening in the short run as well. All right, so let's start to build our model for the short-run cost function. The first variable we have is quantity. We're going to abbreviate that with the letter Q. The quantity is the amount of output that a firm can produce in the short run. Sometimes we'll also use total product for this. Next is total fixed cost, abbreviated TFC. This is the total cost of using the fixed input, capital. Again, this is not going to change at any point in the short run. Our next cost is the total variable cost, which we abbreviate as TVC. The total variable cost is the total cost of using our variable input in production. So in this case, it's going to be labor, and we abbreviate that with the letter L. Next is the total cost. Total cost we abbreviate as TC. This is going to be the cost of using all of the firm's inputs. This is going to combine the total fixed cost and our total variable cost. Remember, we just have the two types of costs. We have capital and labor, our two components in our example. And we can say the total cost equals the total fixed cost plus the total variable cost. Next, we have the average fixed cost, which we abbreviate as AFC. This is our average per unit cost of using the fixed input, K, or capital. So now our average fixed cost is going to equal the total fixed cost divided by the quantity that we're producing. So we're just taking the average here. Next is the average variable cost. We abbreviate this as ABC. This is going to be the average per unit cost of using our variable input, L, or labor. So our average variable cost, again, equals the total variable cost divided by the quantity that we're producing. And our average total cost, or AC, is going to be the average per unit cost of all of the firm's inputs. So the average cost is going to be the sum of the average fixed cost and the average variable cost, our two types of average cost. It can also be calculated by taking the total cost and dividing by the quantity that the firm produces. And finally, our marginal cost, which we abbreviate as MC. Marginal cost is the change in the firm's total cost resulting from a one unit or a unit change in the output. So we can calculate that as the marginal cost equals the change in total cost divided by the change in quantity. We can also think of it as the change in the total variable cost divided by the change in the quantity. The reason we can do that is because the fixed cost is never changing. So the only component of total cost that's changing is the total variable cost. Now here we have a graphical representation of the cost variables. So on the y-axis for both of these, we have the cost. And on the x-axis, we have the quantity being produced. So taking the panel on the left first, we have the total cost, the total variable cost, and total fixed cost. The total fixed cost is constant. In this case, it's at $100. It stays there no matter how many units are being produced, which should make sense to us because they're fixed. They don't depend on how many units we produce. Now, total variable cost, we're going to see that increasing over time. As we produce more and more units, the total variable cost is going to increase. Now, the total cost is going to be the sum of the total variable cost and the total fixed cost. So we see it starts at 100 when there's 0 units being produced because our total fixed costs are 100 when 0 units are produced, and the total variable cost is 0 when 0 units are being produced. Then as the total variable cost increases, as we produce more, it's going to be the total variable cost plus the 100 for the total fixed cost. And that's why the total cost remains constantly at $100 above the total variable cost. And in the panel on the right, we have the marginal cost, the average cost, and the average variable cost. We don't include the average fixed cost in here because it would clutter it up, but the average fixed cost would start high and then go low as we produce more units. Again, we would expect this because the total fixed cost does not change. So as we increase the units, the average is going to get smaller and smaller. Now if we turn to the average variable cost, that's going to decrease initially. It reaches a low, in this case, at 4 units being produced, and then it's going to increase again. Now the average cost, or the average total cost, is going to be the sum of the average variable cost and the average fixed cost. So it's going to start high as well, just like the average fixed cost does. And it's going to fall until, in this case, 6 units that are being produced, and then it's going to increase again. Then we have the marginal cost. The marginal cost is initially going to be high, it's going to decrease slightly for a little bit, and then it's going to begin increasing again. At this point, it's going to increase at 4 units being produced as well. And something worth noticing here and worth mentioning is that the marginal cost curve crosses the average variable cost and the average total cost curve at their lowest points. So both of those curves, the average cost and the average variable cost, are going to be at their minimum where they cross the marginal cost curve. So some observations that we can get from that graph. The average fixed cost, again, is going to decline steadily. When the marginal cost equals the average variable cost is at its minimum point. When the marginal cost is less than the average variable cost is falling. Remember, just like we had with the previous chapter, if you're adding an additional number to something and it's lower than the average is going to go down. Conversely, when the marginal cost is above the average variable cost is going to rise. Again, because the marginal cost, the cost of that additional unit is greater than the average variable cost at that point, it's going to increase the average variable cost because you add that additional unit. If you had a 90 in a class, that was your average, and then the next grade you got was a 100%, because that's above your current average grade, it's going to bring your average grade up. It's the same idea here. And we see the same thing for the average cost that we did for the average variable cost. There's 2 very important relationships that we need to talk about here. First is that productivity and costs are inversely related. So as a firm is more productive, as their marginal product is increasing, their marginal cost is falling. Conversely, when their marginal cost is increasing, their marginal product is going to be decreasing. So they're the exact opposite. And the marginal cost is going to pull the average either up or down, depending on whether it's above or below the average. Now, what if a firm tried to become more economically efficient? So, to start with, if the firm was able to reduce their fixed cost, that would cause the average cost line to shift downward. All the entire average cost line would shift downward because the fixed cost curve shifted downward. Now, we assume that the firm is using the best technology possible. They're operating as efficiently as possible, but that might not be the case. If that's not the case, you can reduce the firm's fixed costs. But again, because this is in the short run, we're not able to reduce the firm's fixed costs by, say, like selling off some of the equipment or buying cheaper equipment or renting cheaper facilities. So that's more of a long run issue. In the short run, a firm can reduce its variable cost. Now, if a firm would reduce their variable cost, that's going to cause all three of their cost lines, their marginal cost, their average variable cost, and their average total cost, to all shift downwards simultaneously. We can see these on the two figures here. For the figure on the left, that's a 50% decrease in the cost of fixed inputs. Again, we don't show the fixed cost or the average fixed cost curve here, but we can see it brings down the average total cost. That's the only curve that's decreasing here. The average variable cost and the marginal costs are staying at the same point. Now, if we turn to, if we somehow able to decrease the average variable cost, through lowering wages or finding something to make the existing workers we have more efficient, that's going to lower all three of those curves. So we have the initial curves and the solid black lines, and the new ones in the grayish dotted lines. So you can see the marginal cost curve shifting down, the average total cost curve or average cost curve shifting down, and the average variable cost curve shifting downwards. So a decrease in the average fixed cost is only going to affect the average total cost. A decrease in the average variable cost is going to cause a shift in the marginal cost curve and the average total cost curve. There are a few alternate specifications of the total cost function worth mentioning, but we're not going to study them in depth, and you're not going to have to reproduce these or anything for the exam or any of your assignments. So the first is the cubic relationship. So as output is going to increase, here we're going to see total cost increase first at a decreasing rate and then at an increasing rate. So that's going to be, for example, total cost equals a constant plus some value times q minus some value times q squared plus some value times q to the third. So our highest exponent is going to be to the third power. We also have a quadratic relationship. So as the output increases, the total cost is going to increase at an increasing rate. So that will have a constant term, some level of q plus some level of q to the second power. And finally, you can have a linear relationship. So as output increases, the total cost is going to increase at a constant rate. So this is if there was no diminishing returns to scale. These can be very useful in some situations, but for our purposes, we're trying to understand the relationship between capital and labor and what's going to happen as you increase, the variable labor, how to deal in the long run with your capital when it's no longer fixed. So we're not going to really go in depth exploring these.